now continue with Wolfgang Hackenberg. Wolfgang, while you're coming downstairs, let me introduce you.
Yeah, okay.
You are an international business executive and a physicist by training. Before joining IQM, you were holding various positions. My microphone is working again, including as a managing director for Nokia Germany. Your career has spanned aerospace, IT, and telecom in various roles in Germany, Europe, as well as in the Asia Pacific and globally. You will now talk about the full stack on-premise scalable quantum computing made in Europe. Wolfgang, the floor is yours. Thank you for being here.
Thank you very much. Yes. No. Yes. Now it works. Very nice. 3:30. This is the end of the conference. It's the end of the afternoon. I'm impressed there's so many people in the room. Can I just ask for another show of hands? Who of you have heard of IQM? That's fantastic news, because since everyone has heard about us, maybe we can choose. Either you listen to me, or there's apple strudel out there. No? Okay, we'll stay with here. I really appreciate it. Where do I click? Here? Quantum computing made in Europe. I've heard in previous presentations today it's about European sovereignty, it's about geopolitical context, it's about getting ready for the future. And that's why I wanted to give you a little update on what IQM is doing. My name is Wolfgang, and I'm the Chief Business Officer. Why quantum computing? I'll skip that because I'm sure you all know that. Who are we? What is our latest offering? Every month it grows. What do we offer in terms of education, in terms of quantum computer, and a couple of interesting services. Two buttons is complicated. So we're trying to address the obvious problems that everyone is trying to address. I will not go into any greater detail than that. You're familiar with that. No need to explain why we're doing quantum computing. Who are we? We are a quantum computer maker. We build them. There's, of course, a lot of companies out there in the ecosystem who build software, who build hardware components, who do quantum computing chips. We're a company that has the whole value chain and creation full stack in-house. So we design the chips, we do all the hardware, we do all the software, we have adjacent services. That means we start with designing the chip. We have our own foundry in-house. We build the entire system. Of course, we buy the fridges, but we build and design the entire system. In terms of software, we do everything. I will go into a little bit more detail later on. Right from the from the electronics, from control, from operate, all the way up to where the higher level software plug into. We have the full value chain in-house, so we're not relying on external foundries. We're not relying on a lot of externals. We do everything in-house. That's a big learning effort. It is a big effort, but it also allows us to accelerate and innovate faster than if we were dependent on industry deliveries. We have a couple of processor generations operational out there. Of course, we want to scale to triple digits and a lot more. I mentioned here 150 because that's visible in the short term, but that's not where we scale. That's not where we end, of course. Everything in-house. There's a race, there's a particular marketing race about number of qubits. I've heard people say it's not all about qubits, it's also about fidelity and quality, and that's why there's different ideas out in the market. We have tunable couplers that ensure higher fidelity, which means we can get a little closer to where we want to get, even without the very high qubit numbers. Point number 4 is an additional activity that we do. We found that in order to get the quantum advantage, there is a way of getting there a little faster for certain applications, depending on the problem, if we design the actual geometric layout of the qubits on the chip in a particular way. That can accelerate things, increase the fidelity, and therefore we offer co-development, co-design between partners, customers who have a quantum problem, and ourselves. We can design the chip, we make it, and therefore accelerate application. and we are a European company. All of it end to end. The company was founded in Finland in 2018. It's a spin-off of Aalto University, which is the technical university of Helsinki. These are the 4 founders. Some of them actually have a background in Munich, Technical University in Munich, Walter Meissner Institute. You may have seen these faces. Can that be read? Yes, I guess so. So we've gone through a round of private financing. To my knowledge, there's no government financing in there. It's all private, VC-funded loans. We have gone through different stages. We've acquired customers. We've opened offices. We've opened the lab, etc. This stops last year, but basically this is continuing. We're today a company of, this is an old slide, it's at least 3 weeks old, so it's old, of about 270, 280 people. Almost half of us are physics PhDs. I'm afraid I'm one of them. We are by now 50 nationality, 5 zeros, so we really believe in diversity. And we have currently offices in Finland, which is where the company's from. That's our headquarters. We're a Finnish company. We have a very large, probably 20-25% of our people in an office in Munich, very large location. And then we have offices in Spain, Paris, Singapore, and we're opening a few more as we speak. The first quantum computer we sold and we got operational was to VTT in Finland. That already happened at the end of 2021, and that's being scaled from 5 to 20 to 54 qubits. In Germany, we work with the LRZ, with the HPC center in Munich, where we also have some of our systems operational and others are being rolled out. In Finland, as you can see here, the small system is operational, the 20 qubit system is operational, and we're currently working on rolling out the bigger one. It all worked fine, on schedule, on time, on quality specs, which is really good. It's also, our quantum computer at VTT is also is connected to and integrated into the Lumi sumo computer in Finland remotely. We genuinely believe that a quantum computer at this point in time may have some standalone benefits, but right now we're looking at a hybrid architecture where the quantum computer would serve as an accelerator to an existing HPC. That's really the use case that we have in mind currently, and that's what Lumi are doing in Finland. As I said, HPC integration, that's currently what we're working on in Munich as well. Not so much as a standalone system, but we work with partners to integrate it hardware-wise and software-wise into existing high-performance computing environments. As I said, we're a European company. What does that mean? Of course, we are registered in Finland and Germany. That's where we do our value add. We do not have any research or other activities outside of Europe. We use European components where possible. Pretty much everything except a couple of chips in the computers. But more importantly, we want to be a member, and we are a member in some of the major European initiatives and bodies at council level in order to be a responsible member of the ecosystem. We really believe in sovereignty in the quantum ecosystem in Europe, and that's why we want to play a leading role, not just in the market, but also in the European ecosystem. High-level strategy, not very surprising. We believe the market has 3 phases. Foundational, does the technology work? Is it useful? Could it be useful? Secondly, quantum advantage. That's when real-world problems with a business benefit will be solved. So not just demonstration, but can we provide a real business benefit? And later on, once that is proven, then we expect applications to go through the roof. We currently feel that we're at the end of the foundational phase, not quite yet in the advantage phase. Technology works, it's operational, but we're not quite yet at the stage where we can solve a real industrial problem. We're working with a number of industrial customers. We are working and developing algorithms together, but we haven't cracked it yet. I guess you would have heard about it if anyone was able to do that. Another way of looking at our strategy is to look at what are we actually doing. So we believe, as I said, in the full value chain. So we design the chips, we design the quantum chips. We even have a design kit, which we open source base, which we put online for anyone to download and use. So we design the chips, we produce the chips. This is an actual, you'll see it bigger in the later slide. This is an actual photograph of our lab just outside Espoo. So in Espoo we have an office, in the basement we have a lab with a significant number of machines, and then a couple of 5 or 6 kilometers away we have the actual clean room. That's a picture there. So we make them ourselves. So we produce the processors and then we integrate the whole thing in an entire system. Here's another picture of it. Private quantum foundry. So we're not sharing it with anybody. This is our own. We own it. We built it. We can use it. Which of course has advantages because you get stability, you get the usage up as much as you want, and it's visible independence, sovereignty. We're not dependent on any foreign foundries here. Also, it helps accelerate the innovation cycle, obviously. What do we offer? My key message is we offer the full system, end to end, and that means, as I've already said, it starts with a QPU down there. All the digital analog instruments, the firmware to control, to calibrate is ours. We do the routing and we do the computation itself. We stop where our software plugs into the higher level Circs or IBM Qiskit or the Atos QLMs. And then of course the entire ecosystem adds value on top with all the various libraries that you can think of. Plus, we want to integrate into any HPC environment as well. As I gave you the two examples in Finland and in Germany, that's exactly what we're doing. All right. We have developed, there's of course a first generation of processors. What you can see here is the qubit layout of a 5-qubit, 20-qubit and a 54-qubit chip. When we talk about qubits, it's the data qubits. I know number of qubits is not everything, still we count them. Not all qubits are data qubits. So we could also boast and say this year we have 144 qubits, that's total, they're not all productive data qubits. So that's something to bear in mind. But these are all real. Same thing once they're packaged. Again, the 5, the 20, and the 54. The 54 is coming out as we speak before the end of the year. Of course, we have a roadmap. Of course, I'm not in a position to share everything, but it will not be long until we come out with triple-digit chips. We not only make the products, we also offer some services. Of course, in the middle, we would install, we would operate, we would maintain, we would calibrate. Of course, that's important. But we would also offer business services. So, for example, some customers say, well, at this point in time, we don't want the whole system. We just want to, we don't want to buy it. We want to lease it, or we want to we want to lease only the QPU and then build our own machine. We're also about to announce a cloud service through the big cloud providers and directly with us, as you like. We can mix and match. And of course, we offer education, but also workshops. For example, we do C-level workshops with some of the big companies in Germany, where the CEO says, we know that quantum is really important, but we don't really know what it is. And we don't know how it's going to be useful in our company and in our vertical industry. And that's why we offer we offer workshops. Oh, it's not on that, it's on the next one. Can I go back? I guess so. No. So we do offer workshops where we sit down with a C-level of a company and their direct reports, 3 or 4 hours, and go through what is quantum computing, what is it not, manage expectations, and try and understand what class of problems can be solved with quantum computers. Is that class of problems available in that company? Would it be of any use, yes or no? And then take it from there. We provide education, proof of concept, co-design, as I said. If you have a certain problem in your company that you think can be solved with a quantum algorithm, then we look at that algorithm, and in our experience, it shows that sometimes it helps designing the actual hardware chip, the geometrical layout of the qubits. If you design that in a certain way, then that helps the fidelity and it helps the speed of your application. That's actually pretty interesting, and that's what we offer as well. What we call the IQM Academy is an effort and a contribution to train customers, to train anyone in the ecosystem on what's a quantum algorithm, where do you start, why is it needed, how do you develop one, and how is it then put into practice. What we have is a free online platform. You can go and take a look at it yourself, where we take people through what is quantum and how do you apply it. It can be for complete beginners. It can also be for advanced specialists. So if you're interested, pick and choose. This is the value creation workshops that I've mentioned, that we do for C-level or for others. And then the IQM Spark is a product that we launched at SQA conference, Superconducting Qubit and Applications conference in Garching in Munich 3 weeks ago. It is a small version of a full quantum computer, hardware for you to buy, end to end. Why did we do that? As my first two examples show, quantum computers are big, complex, expensive, and they take a long time to build. But from talking to customers, we saw that there was a genuine interest in playing with a quantum computer. It needs to be small, turnkey, affordable, cost-wise, because a lot of universities and research institutions and even companies say, we don't want to afford a big one, but we need to build skills. We have a skills shortage in our country and our industry. And so we came up with this quantum computer available to buy now, which is a complete quantum computer. We deliver it, we install it, and you can either use it as is, or you can take a screwdriver, open it, and play with it. That's exactly the purpose of the machine, free for you to use. And it was in the press about 3 weeks ago. The price tag is under €1 million, under 1 million euros, which for a quantum computer is I guess, affordable. It's a 5-qubit machine. As I said, affordably priced. It is designed for education. So don't expect this to be the next HPC machine. No, we're well beyond that. But in terms of affordability, usability, turnkey, I think that serves the purpose well for university research departments, physics departments, computer science departments, etc. And the academy, of course, is a complementing training offering. If you'd like a personal demonstration, we can offer a demo remotely. So it is available. You know, I'm not talking about a vision. This is available. Co-design, as I said earlier on, busy slide, but still, we found that don't ask NMR imaging. NMR imaging offers a class of problems where we found that a square lattice layout is not optimum. For some reason, that was found out. And so the teams thought about, well, what can we do differently? And the one thing they came up with, they said, well, if we change the layout of our qubits from square to star-shaped, then that reduces some of the overhead, it leads to better fidelity, and it means that you can do more computation with fewer qubits. In other words, you get one step closer or earlier to quantum advantage, to solving real problems in specific circumstances. Right, so don't take this as a general thing, but in specific circumstances. So I invite any of you to join us and say, I have a certain problem. Let's see if a different chip geometry layout brings an improvement or not. That's what we do, and that's one example of where it helps having the chip design and the foundry and also an algorithm team in-house. They're in Munich, by the way. And of course, the applications that we support are the ones that you would expect. There's a simulation, there's the optimization. I guess these are no-brainers. Machine learning, partial differential equations. That's what we work on, serving all the various verticals. One use case, you wouldn't be surprised, is battery design. That's an important one, particularly for this country. Also, interesting, I would never have thought of that. We're in a group here working on process engineering. It's actually very simple. I would not have thought about this, but in polymer production, what is the optimum temperature for producing polymers, plastic? So basically, it's a big melting pot. You put monomers in the top, you heat it, and then at the bottom you get polymers. But what's the right temperature? I would have thought that's an engineering problem, long solved, but no, apparently this is an interesting application for quantum calculations. You can, of course, test the whole thing many times, which takes time and is expensive, but apparently there's a quantum use case here. Don't ask me about the details. I would have to put you in touch with some of the team. And perhaps one of the most recent announcements that we've made is we're going to come out fairly shortly with a cloud offering. Cloud offering means either through some of the big players in the market that already offer cloud services, you could then access through the cloud service providers our machines, or alternatively, you could access our machines directly. This is being designed now. We have pilot customers, but my message here to you is we still have room for a couple more, one or two more pilot customers, depending on who it is and what industry. We'd invite you to contact me or contact us later on. We're happy to take pilot customers who could then also give some feedback on what are the requirements, what you need in terms of interface, business model, etc. In summary, and the clock is at 0 now. Before closing, I just want to summarize briefly. We believe we're the only European maker of quantum computers, full stack, end-to-end, hardware, software, services, on-site, turnkey, and this is not a future vision, this is available now. The Spark computer, the little machine, I said the affordable one for research and education, is also available now. The Academy, as I said, freely available. Go on the website if you're interested, beginners or even more advanced people. Co-design, if you're more advanced, feel free to sit down with us and we can look into, does it make sense to develop a different chip geometry for a particular set of problems that you may have. And on the cloud, we welcome pilot customers. That brings me to the end of it. Thank you very much, and that means we're one step closer to apple strudel. Thank you.
Wolfgang, thank you very much. Wolfgang.
I can hear you.
Thank you. Yes, Wolfgang, thank you very much. This was very inspiring, very interesting. I assume that you'll also be sticking around for a bit, so feel free to get in touch with Wolfgang if you haven't yet. Wolfgang, thank you.